Welcome to today's lesson on the rules for determining uncertainty in arithmetic calculations. When we make measurements in science, engineering, or any field that requires precision, we need to understand how errors propagate through our calculations. In this video, we'll learn about absolute error, relative error, percentage error, and how these uncertainties combine in different arithmetic operations. Let's start with absolute error. Absolute error is the difference between a measured or calculated value and the true or accepted value. It tells us how far off our measurement is in actual units. For example, if we measure a rod to be 10.3 centimeters, when its true length is 10.0 centimeters, the absolute error is 0.3 centimeters. Next, let's understand relative error. Relative error is the ratio of the absolute error to the true value. It is usually expressed as a decimal and helps us understand the significance of the error relative to the size of the measurement. The formula for relative error is the absolute error divided by the true value. Continuing with our previous example, the relative error would be 0.3 centimeters divided by 10.0 centimeters, which equals 0.03. This means our measurement is off by 3% of the true value. Now, let's look at percentage error. Percentage error is simply the relative error expressed as a percentage, which makes it easier to understand intuitively. To calculate percentage error, multiply the relative error by 100%. In our example, the percentage error is 0.03 multiplied by 100%, which gives us 3%. Now, let's look at how uncertainties propagate in different arithmetic operations. When we add or subtract measurements with uncertainties, the absolute errors add up. For example, if we have a measurement of A equals 10.0 plus or minus 0.3 centimeters and B equals 5.0 plus or minus 0.2 centimeters, then for addition, A plus B equals 15.0 plus or minus 0.5 centimeters. The uncertainty in the result is the sum of the individual uncertainties. What about multiplication and division? When we multiply or divide measurements with uncertainties, the relative errors add up. For multiplication or division, the relative error in the result is the sum of the relative errors of the individual measurements. Let's see an example. If A equals 10.0 plus or minus 0.5 meters and B equals 5.0 plus or minus 0.2 meters, then for multiplication, the relative error in A is 0.5 divided by 10.0, which is 0.05 or 5%. The relative error in B is 0.2 divided by 5.0, which is 0.04 or 4%. Therefore, the relative error in A times B is 0.05 plus 0.04, which equals 0.09 or 9%. The result is A times B equals 50.0 plus or minus 4.5 meters squared. What about when we raise a measurement to a power? When a measurement is raised to a power n, the relative error is multiplied by the power. For a calculation C equals A to the power n, the relative error in C is n times the relative error in A. For example, if we calculate the volume of a cube with side length s equals 5.0 plus or minus 0.1 centimeters, then the volume is s cubed equals 5.0 cubed equals 125 cubic centimeters. The relative error in S is 0.1 divided by 5.0, which is 0.02 or 2%. The relative error in the volume is 3 times 2%, which equals 6%. Therefore, the volume is 125 plus or minus 7.5 cubic centimeters. Let's summarize what we've learned about uncertainty calculations. For absolute error, we take the absolute difference between measured and true values. For relative error, we divide the absolute error by the true value. For percentage error, we multiply the relative error by 100%. When adding or subtracting measurements, absolute errors add up. When multiplying or dividing measurements, relative errors add up. When raising a measurement to a power, the relative error gets multiplied by that power. Understanding these rules helps us track how precisely we know the results of our calculations, which is crucial in scientific and engineering applications. Thanks for watching.